Hello, I am Nicole Cruz and we are TIBAY. We are a group of innovators where we make life better with efficiency. TIBAY is a Filipino word. It is a noun. Its definition is material strength, sturdiness, and durability. We chose to name ourselves TIBAY because we ensure that our innovation produces high-quality materials as it produces the best performance. And that despite the challenges that we endure, as a group, we're matibay, meaning strong. For our introduction, thermal wall technology has the capacity to make the interior of the house significantly cooler at noon, and when the dilated heated finally penetrates, it makes the area warmer to fend off cold nights. Wall technology itself is composed of glass and concrete. However, containers are added to our innovation for the heated water generated by the sun's heat. So on the left side is the thermal storage walls, and on the right side is an example of a thermal storage wall, a trombe wall. It has the same function as the thermal storage wall, where it is usually separated from the outdoors by a glass wall and is designed to absorb solar heat and release it into the interior of the building. So in this case, we added water containers to warm it using the heat of the sun as a substitute for water heater that we usually have at home. But with this innovation, there are no usage of electricity. So in this innovation that we have, it has two functions where it can give off warmth during cold nights and colder temperature during afternoons or mornings, and it can also serve as a water heater using any electricity.
Good day everyone, my name is Alyana, Alexandra, and Gayos, and I will be discussing how thermal wall works, also known as thrombols. So first, what is thrombols? Thrombol work is a kind of technology that conducts passive heating within a structure. So thrombols reduce the need to provide the heat using traditional methods in construction, which results to the amount of energy used from them is reduced or decreased. The usual standard for thrombols is placing a 2 to 10 centimeters and 20 to 41 centimeters thick of masonry wall. These walls are designed with dark-colored materials and are built facing toward the sun for solar radiation. They are covered with exterior glazing in order to trap sunlight emitted to small greenhouses. This enables the wall to absorb heat in the day and re-emits by night, reducing the need for conventional heating. To put it simply, thrombols are very thick. They are south-facing walls, which is painted black and made of material that absorbs a lot of heat. A pane of glass or plastic glazing installed a few inches in front of the wall helps hold in the heat. The thrombol heats up slowly during the day, then as the wall cools gradually during the night, it gives off its heat inside the building. And as we move on this next slide, we can see in the diagram that using glass results in direct solar radiation, which produces shorter wavelengths and can conduct heat easily. This property is called the Wien's law, displacement, and this is where wavelengths of thermal radiation is effused by walls designed with dark colors increases with the absolute temperature of the body. The exterior of the structure is built with glass panels where heat passes inhibit the structure's interior. Process may take 8 to 10 hours, and with a 20 centimeter thick thrombol, it is then decided that the materials used are 3/4 Pyrex glass and 1/4 fiberglass. And lastly, I'll be showing you a video which incorporates on how thermal wall works, especially thrombols.
Since ancient times, man has used stone or adobe to capture the heat from the sun, store it, and then let that heat radiate evenly through the night. Well, that's a technique that's still being used. We're here at Prairie Woods with Sister Nancy Hoffman to learn about creative uses for solar energy. Now, Nancy, one of the things that we have going on here that you have implemented is called a trum wall. Is that right?
That's correct.
Can you explain to us just what a trum wall is?
Yes, a trum wall is a passive solar device. It was developed in the 50s by Felix Trum, and this optical sun, or the visual sun that we see right here now, it enters the glass, and that allows the optical or the visual light to enter the glass. There's a glass that's about 3/4 inches away from a masonry wall, and the masonry wall radiates in the infrared light from that spectrum, and it stores it in the masonry wall. And then in the evening or during the day, it gradually releases that heat to the space within.
So the heat actually travels through the masonry.
That's
and
correct.
it almost acts as a timing device.
That's correct. I think they say that it travels at about 1 inch per hour.
Now, explain to us how we would use this in the summertime when we don't want heat. How does a trum wall work?
You'll notice right now the angle of the sun is coming in about like this. During the summertime, the sun is higher in the sky. And so usually a trum wall has like an overhang on it, and then the sun hits that overhang and bounces back, or the sun, the angle of the sun during the summertime sometimes bounces off of the glass. And then you'll notice also that we have trees here. And right now we still have some of the leaves on the trees, but during the summertime there are more leaves, and some of the trees over there also cast a shadow over here, so that helps. We also have a ventilation system where the air can circulate in between the glass and the trum wall.
So in the summertime when that's open, the heat isn't captured within that little cavity that we can see between the glass and the
It's
wall.
captured somewhat, but not as much as in the winter, and then it can circulate back out.
And flow.
And flow, yes.
What are some of the other systems that you have here at Prairie Woods?
We have some active solar also. We have a thermal domestic water system at our guest house, and that heats the water for many of our guests, and it also heats the bath water, the wash water, for the laundry, and we have another system at our hermitages. These are little places where people can go to be alone and to be with the land and the earth in a very private way. So they're rather self-sustaining. And
those have solar panels.
These have solar panels, and we are off the grid at the hermitages.
Why don't you talk to us a little bit about your philosophy and why you're taking these great strides to use nature here at Prairie Woods?
We believe that we've received this land as a blessing, and that as Chief Seattle, this land is not ours. We do not own it, but we have been given the privilege to be caretakers and also partners with the land. And we want to live with the land. We want to be able to use the devices that are respectful to the earth and that will provide future generations with the energy that they need. We want to find ways so that we're not using more abundance than we need to.
Well, we certainly appreciate your commitment to the environment and to preserving our natural resources, and I think we can all learn from it.
Thank you, and we appreciate that you are recognizing it, and we appreciate the work that you are doing. Thank you.
Thanks.
Hi, my name is Wyncel Buñag, and I'm going to talk about pros and cons of trum walls. So here are the pros of trum walls. Trum walls are the most flexible solar option.
They work in mild climates as well as in extreme cold. They provide thermal mass in a concentrated area without taking up much space. They can even be used to cool a building instead of heating it. They stop sun drenching, reducing glare on furnishings compared to direct kiln designs. They make for comfortable, quiet rooms with stable temperatures, and they are attractive when viewed from the outside or from the inside. But like everything, drum walls have their disadvantages as well. The only downside on this is drum walls can add up to construction costs, partly because of the glazing, but mostly because the foundations need to support significant extra weight. They can become serious heat sinks, losing a great deal of warmth at night unless they are insulated well. Covering them every night can be a real hassle, especially with external rigid foam panels. You have to go outside in winter, and operating levers or dampers to close the vents is an additional hassle. They reduce daylighting and access to panoramic views too.
Hi, I am Raul Sugue, and I will explain the conclusions that our group has made. The thermal wall will act as a cooling system for a specific area in the house with the use of barrels of water to absorb the heat. When the barrels of water absorb the heat, this in turn can use the hot water to be used for bathing. The mechanism works by first water being pumped in the first water barrel while it trickles to the other barrels while being heated by the sun. It then gets pumped to the shower so it can be readily used for a hot water shower. The advantages of the thermal wall will not only cool the interior of a house but at the same time have hot water ready to be used when you want to take a bath, thus saving electricity on air conditioning and water heating. While the advantages may be good, its drawback might be that on the very cold days where there is no heat for the wall to absorb, there will be also no heat for it to turn into hot water. This would be this application will also be the first of what we can do from the heat from the thermal walls, and it can still be improved upon on future models.